Yes, my things are clear, audible actually. Guys, very good morning. And this is Dr. A.Athief Shah, chairman of AB Semiconductor Designs, who is going to have a 1 hour talk on or going to share my experiences on the deep learning and the machine learning applications. Because we are working on the different kinds of algorithms and different kinds of applications we are going to put on the different algorithms actually. So like what we are going to do today is we are going to find out what are the applications and what are the terminologies which we can implement on respective to my applications. So it's going to be a pure application oriented, based on which we are going to select the model, based on we are going to select the data, how it classifies, how it predicts everything. And moreover, we are going to have an eye on the hybrid algorithms, which is going to be playing a vital role for the research perspectives. Okay, so when you work on the COVID data sets and everything, this is going to be playing a very vital set of considered the hybridization. So now this is what we are going to talk about today. So the sneak peek of my presentation is going to be like this actually. So what is going to be my sneak peek is this is my presentation. I'm going to take the different case studies from the film Endran, which was released on 2010. So we are going to take different case studies from that film. And moreover, like think about it, artificial intelligence is not limited only to a robotics. It is something which has been utilized everywhere in every devices. So we are going to have that mechanism of this film. So we are going to take this as a it is already a case study for the business strategies, which was included in IIM Ahmedabad. But now we are going to take about how the models have integrated. So models have integrated on this kind of every scene and how it has been designed and how it works. So this is what, instead of making a mathematical model, we are going to see how it functions really in a real-time manner. So this is my sneak peek. So I'm going to follow this as a case study, right? So before moving into this sneak peek of my presentation case studies and everything, let me have a brief intro about what is an AI. Intelligence, where do we have this machine learning and the deep learning algorithms to be processed and how it can be done with that. So just a basic intro, what can be done with that, and then we can move to the different applications of case studies, right? Let me have a basic block of an AI. What is an artificial intelligence is? We have to come across this. This is what the logic is, where we have this AI model. You work on the AI model. First thing which we are working, which we are concentrating is about the data. It's important and is very, very important. Design for a highly intelligent algorithm, to design a highly intelligent algorithm. For example, when you want to have an examination, assume you are going to write an examination. Studying is mandatory, but even though that is not mandatory today, but it is mandatory because we need to feed up with our brain with a lot of data so that I can able to get a good marks or I can able to get something else. That is what I require. Designing the data model is important. And second point regarding the data model, today everybody is working on the single data. Right, so everybody can work on the data, historical data, and one can work on image and one can work on the video, anything else. Is we don't work on only single category of data. Instead, we work on the different categories of data, or we can say it may be a dynamic model. At a time it can able to do the voice, and another it can able to get the video. So these two has to be combined, and my algorithm and the designed algorithm should be in the position that it has to categorize these two to do this kind of an application when we work on the real time simulation mode, or when we work on the manual mode. What we do is we download the data and we work on that, and we say what is the accuracy, sensitivity, FN score, etc. But here application, in the real-time logic. We don't work on only one singular data or singular variety of data. Working on the different category of data or a dynamic data models. The dynamic data models are completely different, and that is the logic which we have coming across here. So the dynamic data model are very, very important. It has to process the voice as well as it has to process the video, and at the same time it has to get the data from the sensors also. So please make note of that. We are working on the dynamic data. I'll explain with an example what is a dynamic data model is. So we have a dynamic data model, and then we have a collection. That is what we call the data collections. So we collect all the data. This part is normally ignored in our scenario. Why? Because we work on the downloadable data from the any GitHub or from any university website, but it is not so in the real-time scenario. For example, we are working for COVID, but we need the data to analyze it and to process it. So we are designing a device, and this device will able to take the data and put it on my server. So the data model is important. So please concentrate on this data model. This is the most important cases, because without a data model, you cannot design an AI system. The decision-making system cannot be designed properly. So kindly understand the data model is important. Then we go for a feature extraction. We'll go for a feature extraction normally for the features we have has to be reduced. So we'll take the features which represents the characteristics of all the data. It will have the all shuffling data, and that shuffling data will be represented by the features, right? So we'll talk about the features also. When you talk about the image, when we talk about the video, the features are very, very important for that kind of logic. For the intelligent learning, where we are integrating a machine or a deep learning process for this kind of a mechanism. And then we have a decision box. Based on the value what we obtain, we need to design a decision box either by the theorem or by any thumb rule which can suitable for my application. So hope you have understood what is the basic blocks of your AI model, basic box of your AI model which has been there. So you have data model, you have this collection and extraction, and finally this body is working on that. The learning algorithm is being integrated here, and we have a decision. We are going to design on these cases. We are going to is going to be what kind of thing has to be done. And for example, we are going to take about what other features can be extracted whenever you work on this. And finally, this intelligent learning. So this is how the AI works on. So now the logic comes into the picture is intelligent learning and the data model. So we'll make it up. So let me have a brief intro about the intelligent learning. So everybody knows about it's a machine learning. There is a two categorization: machine learning, not a categorization, machine learning, and the subset deep learning, right? It's a subset of a deep learning. So do not so it has a two categorization. So machine learning has the subset of a deep learning, and the neural network forms the basis of your. So now let me explain what is this about. What makes you to choose a machine learning model? Because you have, as far as the AI is concerned or implementation of machine learning and deep learning is concerned. So what happens here is we are integrating for the AI for cybersecurity and for the biomedical health cases, and even in your IoT. I'll show you how the IoT plays a vital role in using AI. So like IoT, so every diversified fields requires AI. Is what to choose that model, when to choose this model for an application. So when I use a cyber security, which one is better, whether I can go for a machine learning or a deep learning? So one single line makes the difference. That one single line makes a difference. That machine learning and the deep learning is nothing but the number of data used. Number of data used, how much data you have utilized for an application. So how much the data model, how much the size of a data model. For example, if you have the large number of data sets with you, you have to go for a deep learning. Kindly remember, when you have a large number of data sets, the data sets you have will be in TBs or zettabytes. You have a large number of data and it has to be processed. Then we need to go for a deep learning. But as the case of the data size is less, I'm not talking about only 4 data, 5 data. That is not so. When it is having even a GBs of data can be considered. When you have this kind of a data, you can go for the machine learning. So you have these two difference. So think about the data what you have and think about the data model what you have and choose which can be utilized for the mechanism. We can have an example again. Why this difference actually? For example, when we have the 6th standard student or a 7th standard student. He can be trained only with a 7th standard syllabus. That's the mechanism, right? He will be trained, or today's world, the 8th standard is also being trained, right? That is different. So when you consider the brain or capacity of a child or a kid, he can be trained only for the 6th standard if he is studying a 6th standard. I cannot go there. I cannot go to him and train the IAS examination pay syllabus to him. What happens? It normally shatters. My brain gets stuck on that. So this is the problem of overfitting. When you do a large number of data training with the kind of a machine learning models, the machine learning stacks, and we call this overfitting. So we call this the overfitting logic. And as a result, my accuracy, my prediction, everything affects. So that's why we are into the line of a deep learning. So make a note of that. Whenever you start designing a model for an application, please make note of that. What is the size of your data? So that is important. So 4 or 5, you need not very just data sets in your deep learning. You may not. That is, remember what and the size of, and then choose which kind of model can be required. So either you can go for a machine learning or either you can go for a deep learning. That makes the difference. First difference. There is another difference which can be integrated with that. We'll talk about later on by seeing the visuals case studies, right? And we have a different mechanism of that, when the supervisory, unsupervisory, these two learning algorithms comes under supervisory and supervisory algorithm. So what is supervisory learning algorithm is, so when the input and the output are known. So for example, when the students are been studying, like when the teachers like us will teach them, like we know what is the output to be uptime. For example, like what is the pass percentage to be uptime, and we have an ample of data that is called students. So once the input and output is known, we call this as a supervisory learning. Very simple. Input and output is known, it's a supervisory learning. And we have another category that is known to be your unsupervisory algorithm, where we work on only on the categorization of the inputs. I repeat, we work on the categorization of the inputs. So that is known to be your unsupervisory algorithm. And third thing we have on the AI, which is called reinforcement learning. And the fourth, what we are going to concentrate is about self-learning or self-adaptive learning algorithm. So this is most important today. So it's a self-adaptive learning algorithm. So I'll explain you later on with the case studies how the self-adaptive learning algorithm works actually, right? So this is the logic of a brief trees of a learning algorithm. So now we'll move on to the visuals, right? With the case studies, with this knowledge, we move on to the visuals, what is happening, and we'll look at what is happening one by one. Okay. So let me play the first case study. So here is my video. Actually, this is the film. You have seen this film in a lot of TV programs, even your thing, but the prescription, because this film gives you the base for finding out an application and finding out the model for everything, right? So let me start with the basic things of a data model. So what is the real-time data model, what we people are working on over? Let me share this. Yeah, watch this scene as a first scene actually. So it's in Tamil. I'll explain you the scene, what is to be done, right? Yes. Data transfer start connection. Yeah. So now I will have this as a case study right now. Case number 1. What is the data model is all about? Once you look out this previous scene, just visualize yourself. Once you look out the scene, you can visualize in a 2 manners. One is like what happened here is the machine. There is an interaction between the machine and the human. We'll talk about how the interaction using supervisory model with the case studies too. So now let's think about it. It has to process the voice simultaneously. It has to visualize, and simultaneously it has to adjust its pace. It has to adjust its motors and everything which is connected. So what happens is the human is instructing your machine that he has to walk according to him. So what happens here is the voice is gathered, voice is understood, the sentence is understood. And second thing is visualization. It takes the visualization from the human who are been standing behind and takes it out and it processes it. Now you just think about a situation here. When I integrate a single process, when I integrate a separate process for each and every application, my machine is completely without a processor. Like we are just combine all these things using a technique called fusion technique, actually, right? I'll repeat once again. We have a different dynamic data, actually the voice data and your what you say, like it's a video data, both has to be combined, and that has to be combined with the help of a fusion technique. As the fusion libraries are already available in different programming languages, and the fusion can be done with the help of a learning algorithm also. So with help of that, we can able to fuse what is the output. So we are fusing it. We are fusing two different dynamic inputs, and that dynamic inputs are given for the analysis. So here we go for a dynamic inputs, because the dimensionality and the characteristics of the data are different, but still we are making it, and we can use the fusion libraries in the programming. We'll talk about programming later on. Now this scene which clearly gives you the picture about the data which is being utilized is completely different model. They have been utilized with the languages, they have been utilized with the sports, music and mathematics. Every data is dimensionality is differs. So kindly remember guys, when you work on the data, extraction of the data from the any environmental condition and the storage data which can be utilized for analysis is mandatory. So this is where the data science people plays a vital role here. This is where the data science people plays a vital role here. So just remember how the data is going to be, it has to understood by the machine. Important. And when you consider the language model, this is the most important criteria what we people are working today. So how to understand the model for the different application, this is most important. So as far as this case study is concerned, it is sure that the data models can be in any category. So we are not only specific to one certain kind of a data. And moreover, in industries like industry 4.0, we are just integrating this all kind of algorithm with the transformers, even with the transformer machines, example, right? Electrical drives, everything. So domain specific data model are required. That is most important. A domain specific data model. So if you have been like in EEE, if you have been ECE, nothing worry about it. But we are integrating all sort of this AI software with our available devices, but you need to extract the data. That data can be done with the help of a domain specific people. So here I can make a word that it is a domain specific data models are required today to make a device into an intelligent one. So that is the logic which we have to come across here. So remember this guys, domain specific data models are required, right? So don't think that only with the COVID data, only with your image processing, only with the medical healthcare is not only limited to this algorithms. It is being unlimited. It is being can be applied to any kind of a thing. That's what I told you. One single mechanism in the industry which we are following today. It's a transformer malfunctioning. Prediction of a transformer malfunctioning, that is, it has to predict the transformer's malfunctioning before it attains it. So we are developing a software for that. So when you combine all these things of an application, definitely the domain specific data model is required. So hope that is understood by you actually. Next thing what we are coming across is to select the model. What kind of model can be selected for an application? Okay, so let me play in another video for you. Like let me start with the case study 2. The scene which I'm going to explain plays a vital role for all this sort of studies, and you can remember this scene, or you can download this and you can visualize what is happening here. This is the most important scene in this film, and also like in our algorithm also.
Current cut.
Yeah, just watch it over it. I'll just explain it.
என்ன லவ் பண்றேன்னு சொன்னது போய் தானே?
என்ன நம்பு சிட்டி.
அப்போ என்ன உண்மையிலேயே லவ் பண்றியா?
ஆமா.
அப்போ வசீகரன் உயிரோட இருக்க கூடாது. வா, வசீகரனை கொன்னுடலாம். சோல்ஜர், அசெம்பிள். சோல்ஜர்ஸ், we have a target. நம்மள அடிக்கிறதுக்கு நம்மள மாதிரியே நமக்குள்ள ஒரு கருப்பு ஆடு நுழைஞ்சிருக்கு. அதை கண்டுபிடிச்சு பலி கொடுக்கணும். டாக்டர் வசீகரன், நீயா வந்துட்டேன்னா உன்னை ஒலிக்காம கொல்லுவேன். நான் கண்டுபிடிச்சேன்னா உன் சாவு கொடூரமா இருக்கும். Rubber. வசீகரன் நீங்க இல்ல போதிருக்க சார்.
ஆமா ஆமா.
2ல 1 தொடு. அப்போ வசீகரன் இங்க தான் இருக்கா. என்னாச்சு சார்? தலை சுத்துதா? இப்போ சுத்தோ பாரு. Soldiers, rotate your heads.
So I'll just have a thing actually, like I'll explain what is the scene is all about. So here the machine has to identify, or it has to pick up the odd man out from the group of data. You have a group of data over here, and that group of data, from the group of data, it has to find out the odd man out. So the input is there, that's 100 robots, and the output is defined that it has to pick up the odd man out. That is, it has to classify. It's not a prediction, it is to classify the human from the group of inputs. So now you can understand this is a supervisory, because input and outputs are known here. Which come across here is there is a 2 perspection involved in the scene. The first perspection, what has been done here. So it assembles all the data, right? It assembles all the data. We call the robots as data right now, right? You have 100 data over here. And that 100 data, what happens? It has been assembled. It makes a meaningful mechanism so that it can be understood by that. So now you can understand clearly, this is known to be a data pre-processing, right? This is a data pre-processing that it has to be like, make it as a meaningful or a valid data, right? So it has been shattered. You can understand every robot or every machine or every data is scattered over here. And the one master calls it and assembles in a single one so that it can make it easy. So that is that conversion of that meaningful, unmeaningful data into a valid data. That is data pre-processing, which you have been seeing in the scene. And the second point of aspect, what you come across here is the feature extraction takes place, because it has to find out the odd man out, and it has to find the human from the group of data. Right? This is the first problem what we have. It's a supervisory. We fix this as a supervisory. Now we will go for a 2 perspection. One is on the machine learning approach and for the deep learning approach. In your machine learning, what it has take, like what happens here is you have like the robots or a machine which takes the features such as body scanning, and it sees whether the sweat is there and measures the temperature, breathe, and checks the body. And finally, you have the rotation of a head feature, right? So forget about this. The features have been taken. This is called the features. Now assume a condition. The robot is sitting, that is TT is sitting and calling one by one robot to his place, and he marks with manual calculation that he checks the body scanning, he checks what is happening in the temperature and weight, and what is happening on the logic of rotation. It checks one by one. We call this as a machine learning. So when you do a machine learning, we need the feature extraction to be imparted separately, right? So please make a note of that. When you want to work on the machine learning model, the feature extraction, what is to be done, has to be linked, or it has to be done separately, or we can say it is a manual process. We need to go for a manual process, and we have to go for a lot of logic with that. We are having a lot of technique on that because we are taking an image as an example, right? And second thing is the feature extraction can be done as a part. Okay, what has been done on the scene. So feature extraction can be integrated as a part of a learning, and that is the advantage of a deep learning. Okay, we can make a part. Actually, we can make it as a part of the logic, and we can able to do an application. So feature extraction can be a part or integrated part of my mechanism. So that is known to be your deep learning. So this is the second difference and the advantage of your deep learning, why we go for a deep learning. Now, the second perspective of this scene is like, remember, like what is the real problem what we face here is we have all data are similar. We have the similar data, right? So all the 100 robots is considered, which is to be considered, or similar. Why? They are considered to be the similar. Right? The problem is if we have a similar data, and from the similar data, it has to find out the odd man out. So this is the big headache on this. The learning has to understand clearly, right? So, and if you like, what happens is if you have a case, like if you have 10 robots or 10 humans with a male and female, if you have a wide variety of data, I can do some grouping and I can make it out. But that is not the case here. We have a similar data. We have a group of similar data. And from the similar data, we have to find out an application. We have to make a situation here. What model can be integrated with this kind of a logic? This is how we are going to do it. So how it detects, we'll go the reverse side. Actually, we have 100 similar data, and what happens is, let me assume like I'll plot the characteristics of the human and my machine. So let us assume X consists of your machine and Y consists of your human. So first feature what is taken over here is like body scanning. I'll plot it. It fails here in this situation. And second thing is it fails to identify the sweat and the temperature. Third, in the body cutting and everything, diagnosing the body's parameters also, it fails here. So whenever I plot this with help of this scene, so the features are scattered. So there is no kind of a link how to find out. The model decides here. We are being confused how the learning model is confused. So when like a human goes there, you can understand clearly that human, when he sees all the robot which is similar, we can make it only as a similar. Okay, all the robots are similar. There is no human, but machine has to make it understandability. So what can be done with the help of this logic? So what makes the difference? So there is one kind of a feature which makes a difference, that is known to be your rotation of the head, right? So the rotation of head is considered to be the most important cases because that makes the difference between the human and the robot. So what happens is when there is a human cannot rotate for 360 degree, but machine can able to do it. So this feature makes the one single feature that makes the difference. Just that what is the logic here is when there is only one single feature and the machine has to understand by itself. Please make note of that. Only one feature is different, and one with a single distinct feature, it has to understand and it has to classify the different categories. We will employ the support vector machines. So this is where the support vector machines plays a vital role. So you have understood the logic, hope. Like what happens here is like with the one single feature, what you have in the board, like we have only one single feature, and that kind of a one single feature, with help of that, it should able to learn it and should make a classification, even though all other features are failing out. So this is known to be the support vector machine. And when I talk mathematically, like when you have this distant feature, which we call as rotation of head, not rotating of heads, when I draw the line, that is known to be a hyperplane. When I calculate the distance of these two features, this becomes closer to that line. These two features are closer to the line. And by that, my vector machines will understand but that this is the feature which is able to classify my human. So this is how the support vector machines are being integrated to find out or to sort out the problem. What's the problem we talked about is when you have a group of similar data, from the similar data, it has to differentiate the data. So it has to make a differentiation among the similar data. So when you just surf it on the YouTube, you may have the difference of cat and dog. So instead of cat and dog, we have made a chitty as versus your human. So this is the first case study. You have to study about it. Like I repeat once again, you have a similar data. It's a supervisory. It is a similar data. And from the similar data, I have to find out the machine has to find out who is human or the machine which is available. So what happens? It takes the different features and one single feature. So the learning is so efficient here. With the help of one single feature change, it learns and it categorizes. And that kind of thing we are integrating is known to be support vector machines, right? This is the first category of your machine learning model, even though it is old one. But today we are integrating on the deep learning algorithm. We'll talk about this hybridization with the case studies, right? Hope you have understood the first model which has been described here. Now we are moving on to the second model, which is going to be implemented here. Like I'll just show the next case study. Yeah, this is again the next important scene. Please look forward.
சிட்டி உன்னால அவங்களை காப்பாற்ற முடியுமா? Heat 799 degrees Celsius. எனக்கு 1000 டிகிரி வரைக்கும் ஃபயர் ரெசிஸ்டன்ஸ் இருக்கு. என்னால முடியும். சிட்டி எந்த ஊருக்கு ஆபத்து வரக்கூடாது. ஓகே. பயப்படாது. I am Chitti, the robot. காப்பாற்ற வந்து.
Yeah. So this is another scene, like it is again a supervisory model, because what happens in the supervisory model is we know the lot of people which has been available, that is considered as a data over here. And second thing is about like you can utilize it for the rescue system. So this is again a rescue system. So be cautious because it is hard real-time system. Actually, if the deadline fails, what happens, you know, in the scene actually, right? What is the logic here is, right, it is a supervisory model, and also like what we have, like the inputs are known. So it has to rescue the people, right? It has to rescue the people. The target is fixed. So we have supervisory model. So the second thing about data is voice. And second thing is about, we are taking up a logic. We are going to take about a logic, what it has been applied with the two different types. First thing is about like, it has to find whether it has to find the alive or dead, whether the human is alive or dead. That is the first criteria it has to take into an account. So how it finds whether he is alive or dead? By measuring the voices, by measuring your breath, and by measuring even the anything like facial recognition and everything. So it checks one by one. So the trees of if conditions has been drawn on the data. So just data is stored, and I just make it if he has the tree, if he has breath, okay, he's alive. If he has something next, if the condition satisfies, if he goes for that facial recognition or voice, whatever the case, the trees of if conditions has been drawn to classify whether he is alive or dead. So that is known to be the decision trees. So I'll repeat once again, like when we plot or when we draw or when we sketch the if conditions, trees of if conditions on the data to classify the data to get my required target, we call this as a decision trees. We call this a decision trees. So this is one kind of a classifier. This is what is done here. And second classifier, what we can come across here, applying the probability theorem on the data, right? So applying the probability, whether he is alive or dead, the chances of getting alive or dead, right? So applying the probability on the data with alive or dead. When I apply this probability on the data to classify an application, we must know that it is known to be the Bayes theorem, B-A-Y-E-S theorem, and the classifier which we call as naive Bayes classifier. Very simple. It's a naive Bayes classifier, NB classifier. So what happens here, it can be applied for this, but what is the major thing you have to come across here? The conditions and the probability mechanism has to be very precise, and large number of data sets is to be required. Because if you miss one condition on the data, definitely it will create a damage. For example, what has happened in the scene, like even though it is working on the supervisory model, there is no condition that if there is the human is wearing a dress, it has to rescue along with the dress. If he's no dress, sorry, you have to wear the dress. That has not been mentioned in the condition, so it cannot behave it. So the logic which comes into the picture when you work on the decision trees and when you work on this kind of your probability theorem, that is naive Bayes, kindly make sure that all the conditions, whatever the required condition in order to satisfy the target has been fulfilled. So this makes a clear picture about the implementation of all these things on my application. So this is the third algorithm, a second algorithm for that model, choosing of the model. And beware about choosing this. And I tell you, like decision trees can be playing an important role in case of a cyber security, right? When you work on the cyber security and when you work on kind of security breach analysis or an attack methodologies on my different networks, like this decision trees can play an important role along with a kind of an algorithm what we have. I'll tell you, like hybridization. So the decision trees will play a vital role in this because we have a lot of conditional classes which has to be imparted over the data. So we need to go for this kind of an application. So please remember the decision trees and naive Bayes. Think about the data and conditions. If you have substituted everything for fulfilling the target, if it's okay, then you can go for these two things. And decision trees mostly widely utilized in your concept of your cyber security, was analysis of a different attacks on my data. So this is the third application. Fourth here is the most important and most accurate model. What we come across here is this. This is be a categorization for your voice processing also. So look at this scene.
Next.
இதையும் படிச்சாச்சா?
Yes.
எல்லா நம்பரும் தெரியுமா?
தெரியும்.
கமலஹாசன் நம்பர்
24334140.
அது எல்லாருக்கும் தெரியும். நம்ம நம்பர் சொல்லு.
உங்க பேரு?
பஜன்லால்.
பஜன்லால் இருக்காங்க. இனிஷியல் சொல்லுங்க.
ஏ பஜன்லால்.
Right. So here, like the reading aspect, I'll tell you in a different cases about deep learning. So here the logic which comes over here is very important. And the logic which comes across here is like you have a lot of data. Consider you have a 12 data, right? Consider the 12 data, and out of which, again, I have to classify and put up what is the addresses. So I have to make it address. So know your phone number, sorry, your phone number is known. So it has to find out the phone number. So phone number is known and the address is that the name has to be make a classification, right? So you have all these input data with you actually. So what happens in this input data, right? So first thing is about it finds out the nearest concept, the nearest data points. For example, it asks your name and it categorizes the first classification or first categorization will get a Bhajanlal. And second thing, it goes for an initial. That is, we are categorized 3 Bhajanlals over there. And finally, it takes out the address and asks the address, and with the address, it corresponds and classifies the phone number. Right. So now the think about a situation here. It goes for a data points that we call as the nearest data points, finding out the nearest data points with the help of an iteration. So k equal to 1, what are the nearest data points? If k equal to 2, what is the thing? K equal to 3, what is the thing? So when you go for increase the k value until I find the data, that is the target to be achieved. This is known to be KNN algorithm. So KNN classifier, that is k nearest neighborhood logic, right? So this is the logic which is used to categorize the data, depends upon finding out the distance between the data points, which we have shown you. Like we have data, first thing it checks out the name, it categorizes and it goes for that. It is not an so with the help of a data points, it takes about the data and it gives categorize the data and to find out which is being the classified target. So this is the fourth case study you have to come across here. This is the KNN. So this is the logic which we have come across here. And the fifth algorithm, what we are going to come across is very simple algorithm that it's not a simple, it's a base for everything. That is artificial neural network. And the artificial neural network can be considered as a machine learning. But when you increases the numerous of layers and layers on artificial intelligence, then we call this a deep learning algorithm. So let me have this kind of an application. What are all the things you can come across here? And what are the logic which we are come across here? I'll just give you an example here, right? So the deep learning, right? Before that, we move to ANN. So ANN, what happens here? It is similarly like our brain properties. It is basically your brain and all the body consists of dendrons, axons, and everything, synapses, everything. So I don't want to go into that side. Let me have the brief thing about that. ANN. Whenever we just do the studies, what happens here is we used to take the input from our organs, sensory organs, process in the brain, and we do the behavior. So the same model has been designed. We need an input layer and we need an output layer. And what happens is hidden layer, because what is happening in the brain, nobody can visualize it. Okay, nobody can withstand you. Nobody can know what is happening in the brain. So that is why it is known to be the hidden layer. Right? So you have an input and you have a hidden and you have a output layer, which is to be processed. So similar way, ANN has these 3 layers. So now what happens is, remember input layer and you have a hidden neurons, and every features has to be connected or interconnected with the neurons to produce your output. So this is the logic. So what is the interconnection? Once it interconnection, it gets an output. So this is a model. This is a simple model which is going to be operated, right? So now what is the logic which we are coming across here is the first thing which is being done over here, which is the model which comes across here. Let us have an example. The example is, let us assume you are going to train the students, group of students. The teacher has to train it. So as you know, it is a supervisory. We need a mark over here, the percentage of marks to be obtained and the input to be obtained. Inputs are there and the output is known to you. So what happens in the output and input is something like the output is like what happens if I get 70. The pass percentage may be 100. If I get 70, what I do is with the help of a 70, I'll just train my brain again and again by keeping the test, by writing the examination again and again until I get 100. So this is the thing. So I'm taking output as a major criteria and revert back to my network. And this is known to be your back propagation algorithm. So this is known to be your back propagation algorithm. So output, until I obtain my targeted output, I'll just keep on training my hidden layers, and I'll just keep on changing my all sort of applications on my hidden layers, input biases and everything. So that is known to be your back propagation. And there is a very important problem in the back propagation that we called as a gradient problems. We'll talk about later on this with the gradient problems. We have the gradient problem whenever we solve with the back propagation. So this is something on one side of ANN. And next side of ANN, we have feed forward network. That feed forward network doesn't depend upon my output. Simple. Connected with the input and output, you'll get everything. So you have a hidden layer, input and output, connected everything, do mathematical application, and you get it. I don't bother about your output. I don't bother about the output, which is not an output which is obtained, which the output feedback. In general, we can say the feedback. Right. So one category of the artificial neural network, which plays an important role, is a machine learning model that is known to be your extreme learning machine. It's a feed forward layer, right? It's a single feed forward layer. So it's the most important algorithm, but even though it was being invented in 1997, but still it is on the darker side. Why? Because it has not been utilized properly, to be frank with you. But nowadays it is gaining its more popularity by integrating with the deep learning algorithm. So here the extreme learning machines plays an important role. So whenever you go for an image, whenever you go for any kind of classification or a prediction of your stock markets, when particularly it has been utilized for predicting your electricity bills, right? So most importantly, this ELM play a vital role when you have electricity bills, when you prediction of your electricity bills. So this is the most important criteria why the ELM plays an important role. It's a single feed forward network, it's a classification, or it is a category of an artificial neural network. And then once you increases, as we talked about earlier, when the data size increases larger and larger, yes, which has been increased is also increased to a exponentially. So as I told you, overfitting takes place and we go for a deep learning algorithm. So this is what the deep learning algorithm goes into the picture. So now we'll classify, we go for a case studies one by one, and we'll make it out what is the deep learning's application on the devices, right? We'll categorize as a one single application, and we'll make it out each and everything. So now I just play the scene, like what happens in the scene. You can take about this an example.
அசீமோவ் விதிகளின்படி
watch out this scene.
தயாரிக்கப்பட்டது. காரணம், போர்க்களத்திலே ரோபோக்களும் மனித எதிரிகளை கொல்ல வேண்டிய சூழ்நிலை ஏற்படும்.
Let me check your color and shape perception. Take the red cube up and put it on the yellow pyramid.
Not possible.
Then
Reverse is possible. Yellow pyramid.
Yeah. So now just look at the scene actually, right? What happens is the color perception has been taken care. Images are taken care simultaneously to answers clearly. Actually, the machine answers clearly and machine able to recognize what is happening over here. So now what happens here is this is a deep learning algorithm. This is an example of a deep learning algorithm. So what happens here is, like, first category of deep learning algorithm, we call this as a convolution neural networks. Actually, it's a convolution neural network. What happens here is, so you have a different things. So feature has to be extracted. That is, the shape has to be extracted. In order to answer the question from the panel, it has to take the different shapes. Actually, it has to extract the different shapes. Shape extractor has to be taken care by the machine. Okay, it has to taken care by the machine. So what happens here is, we have end-to-end data. We have a group of data over here. We have a lot of data over here. And we need only what is the cube and what is the shape of a cube, because you have to understand from the machine perspective, right? What happens here is, we have to take out from the machine perspective. Please understand that logic which is being coming across here is, like, the machine has to understand the shape of a triangle, cube, and everything. So like the images are there and images have taken, and one single case it has to extract the what is the shape of triangle. It has to extract the shape of your and everything. So what happens is, what is being employed over here is, you have data, that is pixels of data. So what happens is, I'll integrate a filter maps. and the filter maps are convoluted on my data. That is rolling. In general, we can in Spanish, in the convolution means rolling. I'll roll my filter on my data, right? I'll roll my filter on my data so that my feature maps can be extracted. So my feature maps can be given. So I can get what is a cube, what is a triangle, whatever the case, cube, what is the shape is mentioned, I can able to get it out. Combine in a feature maps, all these feature maps, and it is being utilized for the training. That is the training with the back propagation or a feed forward can be integrated with that. So this is known to be the convolution neural network. So that is why we have pooling layer, max-4 layer, everything. But I don't want to go into that. So a general concept like what is convolution layer is about. So you have the image and the pixels of data. You have the filters. Roll the filter over here. That mathematical operation we call this a convolution. And from the convolution, I'm just making out all the features what I want. Design a feature map. And that feature map, whatever the features you want, you just integrate, increase your pooling layer, and we'll get a feature map. And the feature maps can be trained with the help of your back propagation algorithm or a feed forward layer. So that I can able to categorize the weight and take a decision. So this is known to be your convolution neural network. And whenever you just want to go for any kind of a logic of visual analysis or image or video analytics, kindly go through or you can opt for a convolution neural networks. You can opt for a convolution neural network. So that is the logic. So you can post this actually important logic. So remember, whenever I have go for video or images, when you want to analyze this, you can opt for this CNN. So CNN will have better performance when compared to the other algorithms of a machine learning. So this is the one kind of a logic what we have here, right? So this is the one kind of a logic, right? So the second kind of an application when the deep learning is concerned, we gone for a lot of deep learning logic over here. Let me have this PPT over here. I'll just go for this PPT again. So I'll refresh it. So we have stopped up to CNN. Now I'll go for all the algorithms. So everything has been, now we are testing out with an application. Let us assume like we have completed the CNN. Now we are going for a first application with the help of a CNN. That is a computer vision system. Right, computer vision system, and we'll take the case study of Indian film as a emotional identification or emotional studies which is being taken care in the film, right? So emotions are imparted on the machine. So we'll take this as an example. So I told you like whenever you go for a video, image, and logic, we can go for a CNN, right? CNN for an application. The second important application what we have to come across here is this. Actually, we have designed this based on machine learning, but now we are going for a CNN for the COVID. So what is the mechanism over here is everybody knows about the facial recognition system. So nowadays the facial recognition system is being imparted on any kind of an application, such as it is being utilized for an attendance monitoring. It is being utilized for any cases. But think about a situation where the facial emotions can be recognized and with the help of the symptom. Can you understand what I'm talking about? Like kindly understand the concept. Like instead of facial recognition, if I can recognize the emotions from faces of the different human and I can relate it with a symptom, I can able to make a very intelligent system on that logic. So you can understand this kind of algorithm can be integrated. CNN plays a vital role along with the GAN. So general adversarial networks. So these two algorithms plays a vital role for this. So how can I make this? You can very well surf it in the net called FACS system, facial action coding system, right? It's a facial action coding system where it represents like the features of the faces along with the different emotions, right? Different emotions, and the research we have to go for that. We have to relate those emotions with that of your symptoms. That is different. So already we have proved that it can be utilized for the Parkinson's diseases or the age for the people above the age of 60. So whoever is experienced with the age of 60 with the facial emotions, we can able to understand what is the logic, right? So this can be integrated. So the features which can be extracted with the help of a fax, and you can put up a threshold for each and everything, and you can train with the help of the logic. So CNN plays a vital role for this kind of an application. So the facial emotions, other than the facial recognition system, other than the facial recognition based attendance system, we are today's research, we are concentrating about a system which can able to relate a facial emotions along with the symptoms, right? With the symptoms of a diseases. So this is the most challenging part of a research, but actually people are working over here. So symptoms related with that of my facial emotions. So if you want to start this, kindly work on the facial emotions, right? Kind of facial emotions, recognition of the different facial emotions using the deep learning algorithm, where you can able to learn one by one and see what is happening. So this is about your face emotions mechanism. This is a fifth category of an application where the CNN or even GN we'll talk about later. So deep learning plays an important role. First application. And the second application, what we come across here is the speech and document reading. The speech and the document reading. So the deep learning finds its most important methodology for a mechanism, right? What happens in this mechanism here is, so it has to understand the word and it has to predict the next sentence. It go for the prediction. So here we go for RNN, recurrent neural network, and nowadays RNN is now replaced with not a replacement. It is being utilized with the help of LSTM, long short-term memory. Right, the long short-term memory is being utilized for this kind of an application. So this is a one kind of mechanism what we have actually. So for the document and speech recognition and everything for your studying your OCR, that is optical character recognition. So these LSTMs will play a vital role for the logic. So now we'll see an example what model can be integrated over here. So let me have the case study over here. Now just watch out the scene carefully how the Chitti reads it actually. So again, the mechanism. So watch out this. Just read. Just think. See how the Chitti reads.
Books படிங்க. எத்தனை பேஜ் இருக்குன்னு என்றாரா?
Now, this is the most important criteria for learning algorithms, integrating a learning algorithms. So whenever you just imagine a problem, first thing is machine has to read by itself, right? The machine, we know how to read it, right? We know how to read it. We are talking about in terms of a machine perception. So just think about an idea what we have, right? The idea which is coming across here is you can have a decision over here that the document is given to the machine and the machine reads how it reads actually. So how it reads actually, what is the logic which has been done here? You can see one single significance over here, the tilting of a book in both directions, right? It goes for this and again it goes for this. So one to one direction, your east to west and again west to east. So this has been happening actually, right? So bidirectionality reading it's been taking place. But what is the exact problem which is been taking when you work on this kind of your document reading and everything feed on this data? So what happens here is like once it reads the document, it reads the first book and it comes, it learns, we'll see what is the mechanism. The second book is given. So what about is the knowledge is updated, right? The knowledge is updated because first book and the second book, the knowledge is updated. Third book, again, the knowledge is updated. So when I come to the first book, it should not be struggling out, right? It should read it as fast as possible and it should give the details and the details has to be stored. But this is a problem. So now you can understand clearly, it goes for the bidirectional logic. It goes for a bidirectional. It reads a bidirectional mechanism. And this can be done with a model called BERT model, bidirectional encoder transmission and reception. That is your BERT model from the Google. It is a BERT, B-E-R-T. And what this BERT model is consist of? So the BERT model is consist of a transformer LSTM or a transformer neural network. So we have a category of a LSTM that is known to be like an attention-based LSTM. And this transformer belongs to that category. That is the transformer neural network, which plays a vital role for a language modeling or a reading of a data. Reading of a data, that is reading a book or reading a document. So where this is scenario where it is being utilized here is the machine is being utilized to retrieve the data which is being there, back to date data which is being retrieved. I want to retrieve the data year back or 5,000 year back or 10,000 year back, which has been long significance. For example, when you consider 5,000 years of data ago data, the data consists of all kind of medical transcriptions which is to be utilized. But today's letters are different. So with the help of a database, these kind of BERT models can be utilized to retrieve the past information so that it can be suitable for my modern area. So this is what the mechanism which we are working today. We are working on the 12th century and 13th century letters, and that letters can be utilized for kind of an application where that can be suited for the today's scenario. So this kind of an application can be done with the help of this kind of a BERT models. Even though the BERT model is a language model, but we can design it for the mechanism with the slight changes in my attention LSTMs or the transformer neural networks what we have. So the model I want to show you here is, this is the model which is coming across here, and this is the model which comes over here for any kind of a understanding of your language, or you want to write the document on the things. Everything is designed on this, based on this model. So just now look at this have the model which is you have. So first thing what the bird does is it extracts the knowledge. It extracts the different kinds of knowledge what you have. Something like a noun, what is like, if it is we are working on the temple, it is considered a temple, right? Place, everything. So we call this as an entity. So knowledge extraction is being taken care, and from the knowledge extraction it goes for a knowledge graph. It is the most important cases, knowledge graph. The knowledge graph is nothing but establishing the relationship between the words which is being derived or extracted. So this is being done with the help of a mechanism called Lsi clustering. Okay, this is where the unsupervised plays an important role in our technique. It is Lsi clustering, right? Okay, so Lsi clustering in general, we can say it is a semantic relationship between the words has been established, and we draw this as a knowledge graph by extracting the different words, and that is to form the sentence. And with the help of a network, I can able to predict the next sentences, what is to be done. And this is how the machine reads your document, and the model can be formed. The language model can be formulated here. So this is the one kind of application where you can use it as a language translator or an OCR technique, or importantly to digging out the past data so that it can be utilized today in the today's world, because we are facing a lot of problems in today's world that can be utilized for that kind of an application. This is something like the advancement of an LSTM. And the knowledge graph can be drawn with the help of another scenario we call this a graph neural networks, right? It's a graph neural network. We train it. Once the relationship is being established, we will have a logic that we called as a graph neural network that can be made it out to find out the sentences and to train it ultimately. So this is graph neural network. This is another category of your neural network that has been finding out here. And in this graph neural network, you can able to, and another application which you have it here is, you can utilize for a sentimental analysis. That is most important. That's a sentimental analysis what we are talking today. You can integrate with the help of a graph neural network or with the extraction of a messages, what I'm talking about, right? What I'm talking about with the messages, right? So type of messages you want, and what kind of reviews you have been posted, and more importantly with the graph neural network you can able to categorize everything. So it has been the fourth application what we finding out is in the sentimental analysis, which is plays a vital role. There is there is a device called you know, like, I don't know how many of you have experienced this device actually. So let us consider a device actually, right? It is already integrated in the supermarket actually. Supermarket is manual, is being done over here. Now let us take this, right? Whenever it's an idea, right? So you can go for a supermarket, or whenever you just watch over the films, or whenever you are in Ola, you're just watching out the advertisements, right? My basic question is, can I able to find out which advertisement has the better impact on customers? Yeah, if yes, how? That is, the logic is we can integrate a camera and we can able to find out the features what I talked about, the facial emotions, right? So with the help of a facial emotions, I can able to categorize the type of customers in accordance with the type of products, right? If the product is being attractive to one such a kind of a customer, I can able to attract the customer and I can make him to buy. I can make him to purchase the product. That is possible in today's world, right? So if you are seeing the film, if you are seeing the TV ads, of if you are going in any cabs, you are seeing this, and any one kind of thing feature which can attract you, and that can be captured with help of this model, and I can make it a logic, and I can give to I can make a sensitive to the product people, and the customers can be insisted by, or it can be made the customers to purchase the product, right? So this is possible with help of a facial emotions, all this kind of stuffs, right? So this is where the sentimental analysis plays a vital role. So kindly understand, the sentimental analysis not related only with the posting with the reviews. It is utilized to identify the fake IDs, fake images, and most importantly, the influential nodes or influential users in the network who has the control of all the network. So it can be determined with the help of this kind of a models. And I told you, like, it can be utilized with the BERT as well as with the graph neural networks. It's another category of neural network which comes into the picture that we call as a graph neural network. So this is the applications of in terms of your LSTMs and other circuits. And the fourth application what we are coming across here is this. Like before that, before seeing this film, sorry, before seeing this slide, I just go for a video. Just look out this. Yeah. So this is about the delivery scene and the pregnancy scene which is happening. It's a supervisory learning algorithm. It's a deep learning algorithm. Just watch it out this.
நான் முயற்சி பண்ணதான் முடியும் சனா. அதுக்கு மேல எல்லாம்
நான் ட்ரை பண்ணிட்டேன்.
நீங்க யாரு? டாக்டரா?
இல்ல, I am Chitti, the robot.
ரோபாட்டா?
சிட்டி இது வந்தாலும் முடியுமா? Why not?
சாரி, எங்களால இதை அனுமதிக்க முடியாது. இது லேப் இல்ல, லேபர் வார்டு. 2 உயிர் அண்டர் டோட்டல் ரிஸ்க். இவ்ளோ எக்ஸ்பீரியன்ஸ் இருக்கிற எங்களுக்கே திஸ் இஸ் நைட்மேர்.
என்னால முடியும். சனாவோட எக்ஸாம்ஸ்க்கு நான் படிச்சிருக்கேன்.
சனாவால இது பண்ண முடியாது. சிசேரியன் பண்ண you need qualification and experience. It's against the medical law.
சிசேரியன் தேவையில்லை. என்னால நார்மல் டெலிவரி பண்ண முடியும்.
எப்படி முடியும்? 2 பேரும் செத்துவாங்க. She is bleeding.
பிளாஸ்மா டிரான்ஸ்ஃபியூஷன் பண்ணலாம்.
blood pressure ஜாஸ்தியா இருக்கு. எந்த நேரத்திலும் பிச்சு வரும்.
மேக்ஸிமம் ரெஜிமென்ட் கொடுக்கலாம்.
pelvic disproportion. normal delivery possible இல்ல.
பாசிபிள். இம்பியாஸ்டமி பண்ணலாம். பழைய கால பிரசவம். இடுப்பு எலும்பை விலக்கி பண்றது. presentation of the program of the presentation of the lecture. சத்தம் போடாதீங்க, பையன் பயப்படுறான். You are making history. முதல் முறையா ஒரு ரோபோ பிரசவம் பார்க்குறேன். பையன் உங்களை மாதிரியே இருக்கா. பார்க்குறீங்களா? டாக்டர், வைஃபை ஆன் பண்ணுங்க. அல்ட்ராசவுண்ட் வீடியோ ஸ்ட்ரீம் பண்ணுங்க.
My God, it's unbelievable.
Yeah, so here comes the most important problem and the most important mechanism the artificial intelligence or a learning algorithm has to be designed. So here what happens here is, so now the machine has to transfer or stream the video on the network, right, without any affecting the logic. So what's the problem? You just now we are in the webinars and the online classrooms are going over here. But what is the problem in this scene is like it transfers, it streams your medical ultrasound videos. Normally, medical ultrasound videos takes a larger bandwidth, right? And there is a Wi-Fi connection, and through which every device is connected to the Wi-Fi will get the data. This is a simple IoT application, Internet of Things, right? So every device will get all these things. Data is transferred from one area to the another, right? So now what happens is like image has to taken care. That is, the video has to stream it in live and without any drop or packet losses in the data. So how it is possible? Because when you do a Wi-Fi connectivity to the whole network, there is something like when you do connect a lot of devices with that, definitely the signal strength and everything may have a chance to lose it, and in that case the data packets may lose. So there may be like a misconception between the data transfer and the data received. How the learning models can solve it? This is where we go for a hybridization. So I'll just make it my PPT over here. This is the block diagram of this actually. So you can see here the original ultrasound video sequence is converted into frames, and this has been encoded with H.264. What happens in that film is that film encodes with the MPEG-4, but here just an example we have taken H.264, and it calculates the bit rate. And the most importantly, you can see a block called data set, and the data set is consist of the content type, right? The content type and the bit rates. So the type of content is being extracted. This is where the CNN plays a vital role, or GAN, General Advisor on Networks, plays an important role for a segmentation. That is whether it is a slow motion or a fast motion or medium motion. The content has been extracted and segmented. And from that, I'm just combining with the cell network. The cell Wi-Fi, I'm combining a signal strength, what is the bandwidth, everything. I am combining with the number of users, everything I'm just combining with a parameter, and I'm predicting which in the which time, the time versus, that is the protocol. What happens here is if the signal strength is high according to the number of users, we have to manipulate it. So in accordance with the number of users, in accordance with the bandwidth which is available, which data can be sent at first, which content can be sent in first, can be predicted with the help of our algorithm. Here you can use an either LSTM or any prediction, because LSTM will have this own mechanism significance over here. Just for a content type, I'm extracting the CNN, and for that mechanism, like for predicting the next path, what is to be the path, everything, I'm just going for the LSTM. So this model, after that, you have to decode it and reconstruct it. We can see the video. This is the most important model in today, where for transmitting the video and video analytics in over the IoT network. Whenever you want to have an IoT network and you want to transfer the images over the cases, so this idea, what I'm talking about, plays a very important role. So this can be integrated or designed as an intelligent gateways. Okay, this is most important as an intelligent gateways, where it can decides everything and transfers according to that. The film which gives you the clear picture, and the block diagram, the technique which is integrated on that scene is being drawn as a block. So this is the most important criteria what we have. So the clubbing of an artificial intelligence or a learning model to your IoT network. Not only in IoT network, it can be utilized in a 4G or 5G. Any case, it can be utilized in the cases of any network. So this model plays a vital role for a kind of an application. So this is another application. So starting from the hinge of your hinge of your basic concepts, and now we have talking about the hybridization of learning models, right? Hybridization of your learning models. So this is most important. And second hybridization is what is there is like, we are just integrating the machine learning over the deep learning algorithms to have an effective mechanism. So here, instead of LSTM, I can use ELM, simple, right, for the prediction of a path. So you are using for designing an effective model of a deep learning, we are integrating the machine learning model over the deep learning model to get a very accurate new model that can be suitable for my application. This is second hybridization. And third, we call this a self-adaptive learning algorithm, where it is a one-time training and it learns from the environment. To train and again it trains from the environment. The best example is the document reading. What I'm talking about. Today's world, like we are working on this self-adaptive learning algorithm for the document reading, because every time I cannot make the book to be trained. If one book is trained, with the help of that knowledge, it has to train the next book. It has to get trained by the third book. So once it is trained, with the addition of all the books, it has to adjust itself for the training model. So this is self-adaptive. That's a third hybridization, what we call as self-adaptive learning model. So these are all the models which finds a very, very important application in all kind of stuffs what we talked about. So starting from the sensors, industry 4.0, sentimental analysis, facial emotions, voice recognition, document reading, BERT, and you have a language model, what I talked about. And this is something like very new, that is clubbing of your IoT with the kind of a stuff with the intelligence model. So everything plays an important role in case of communication. Starting from the communication ended to any kind of a domain, it plays an important role. So these are all the applications what we have it. And finally, what you want to go for this. So what we suggest is, don't only stop your model with only with a system or a PC. Deploy it in the hardware so that you can see what is the real-time stuff, what it has been happening. So what the real-time stuff is going to, because the applications what we talked about is kindly a device, right? Device-oriented application where the learning model or intelligence runs over here. But we don't stop only with the software, run over here, check what is true, positive, true, negative, confusion matrix. That is good, but don't never stop with that only. Just deploy on the hardware what is saying. So I suggest you to go for the two important hardwares which is being utilized today. We go for NVIDIA Jetson Nano board, right? What we are doing it. NVIDIA Jetson Nano. So you can do it. It supports all kind of your Python libraries, because Python you will be familiar with all the cases. We have Python libraries, and that can be import on this that can be deployed on my hardware to test the real-time applications, right? So this is the logic what we have. This is one kind. Other board you can do it is Max Arduino. It is, though it is not mentioned in the slide, you can note it out. It is Max Arduino board, where you can use this board only for the image processing kind of an application, right? You can use it for, because this NVIDIA can be utilized for an IoT kind of stuff also. Clubbing of artificial intelligence or a machine learning model or deep learning model on the IoT. But Max Arduino, what I'm talking about is, it is mainly meant for that image processing. And even though the IoT is there, but the Wi-Fi is there, but as far as this NVIDIA is concerned, so you can try with the beginners, you can try with the Max Arduino board, and after that you can work it on this your NVIDIA Jetson Nano. And after that, the programming language is what we come across is Python. It is normally, this means normally utilized. Python is normally utilized. But I suggest you that you can go for a Go programming. It is from the Google. So nowadays the Go is improvising little bit, but not in the floor of industries as much as Python. but the Go is improvising. My prediction, but because we are working on the prediction of algorithm, my prediction is the Go can occupy the position of Python in soon within 2 or 3 years. So kindly have an eye on that Go programming also, and the combination of your procedure language with a Python, such as C with Python, Java with Python. So we just combine these two programming. C with Python we call Python, right? So this combining procedure language along with Python libraries. So just go for that also. That also plays a vital role when you go for a deployment in the hardware. And for the artificial intelligence, we have a programming called Prolog, that is programming in logic. This is interactive language where it is plays a vital role. In case of electrical vehicles also, we have a board which designs with this Prolog programming. We call this a PC station, right? It is a PC station boards which works on Prolog programming, where you have artificial intelligence and machine learning are integrated, and that finds its suitability in the electrical vehicles, right? It finds its suitability in the electrical vehicles. So once you start doing it, okay, that you have started with Python and doing a lot of stuffs actually, but still deploy it in the hardware so that you will face a lot of problems with that. Kindly interface with the cameras, high definition cameras, see what is happening so that you can build up a product. So we need build a product, not like a simulation side, right? So kindly do that. If that's the case, it is good for our country and for your future also. So this is how the logic goes on. And let me wind up. I have taken more than 1 hour actually. So thank you for your kind cooperation, and thank you Group 90 who have given this opportunity to talk about my experience and share my experience with you guys. So if any queries, post it on the comment box. I'll just answer you whatever the queries you have. We'll make it out. Okay. Thank you. you.